Hi, in this session we are continuing with partitioned table. In this we have seen range partition without max value partition. Now we will create a table based on the range partition using max value partition. Max value partition is nothing but the default partition. When a record is not mapping to any of the existing partitions, then that record will be moving to the default partition. If the default partition is not there in the partitioned table, then the record which is not mapping to any of the existing partitions, that record will be rejected, means will not be inserted into the table. To insert those kind of records, we include max value partition as a default partition with range partitioned table. Max value partition is valid for range partitioned table only. This max value partition must be present at the end of all the partitions. It cannot be in the beginning or middle, it should be at the end of the partitions. Let us see here, create table EMP part range 3. We have 4 columns: employee number, employee name, date of birth, salary, and then we started the partitioning clause. Partition by range on employee number. Employee number is number column, the data type is number. Partition P1, P2, P3, P4. The first one is values less than 10, second one less than 20, third one less than 30, and the last one is max value. The max value must be present within the parenthesis. Table created. Now let us see some of the other possibilities. When max value is allowed, can it accept min value? Or instead of values less than 10, can we add values between 1 and 10, 11 and 20, like that? Let us see those kind of exceptional scenarios. Creating EMP part range 4 table with values between 1 and 10, 11 and 20, 21 and 30, and employee number is a number, missing less keyword. It is expecting values less than, but between is present. It is giving the meaningful message. So except values less than, no other keyword is allowed for range partitioning. We cannot use between operator here. We need to specify less than a value. So this kind of usage in the range partitioned table is invalid. Next, based on the date column, we are creating a range partitioned table based on date of birth, which is a date column. Now here we used values less than 31st December 2010, 2011, 2012, means 1 year data, and then here we used no max value. Let us try no max value, will it accept or not? It is not accepting. Partition bound element must be one of string, date, time, interval, literal, number or max value. It can be a character, date, time or time interval, number or max value. No other keyword or value is allowed in this place. So no max value is not allowed. Next, let us try with min value. Instead of max value, we tried with min value. The same date column is used for partitioning key. It is also not allowed. Again, it is displaying the same message. It must be string, date, time, interval, literal, number and max value. Except max value, no other keyword is allowed in this place. So min value is not allowed, no max value, no min value, this kind of keywords are not allowed. Only max value is allowed, or it must be a number or a date or a character, or it must be interval, literal time interval. So these are the exceptional cases, exceptional scenarios. Now let us see our normal scenario. Let us create a range partitioned table based on a date column with max value partition, default partition. The same DOB column we are using as partitioning key, values less than 31st December 2010 and then 2011, 2012. So up to 31st December 2010, the values which are less than this date, all those things will be entered into partition P1. If it is 1st Jan 2011 to 30th December 2011, it will be going to partition P2. That means 1 year data. Next 1 year data will go to third partition. Beyond 30th December 2012, including 31st December 2012. Beyond this, all the data will go to the default partition, max value partition. So table is created here, creating another table 5. Now we are using character column as partition key, means we are partitioning the table based on the character column, which is employee name. If the values less than A, less than G, less than Q, max value. So when we say range partition based on character data, it will consider the ASCII value of the given character. Based on that, it will decide to which partition it has to be moved. Table is created. Now let us insert data into this table, EMP part 5, which is range partitioned on character data on employee name column. Less than A, less than capital A will go to the partition P1. Less than capital G will go to P2. Less than capital Q will go to P3. Rest all will go to default. Capital A, it has inserted. Capital A, small a, inserted. There are 2 records in the table. Partition P1, nothing. P2, yes, 2 records are there because values less than A. So if you insert A, it is not eligible into first partition. That will go to the second partition. A also has gone to the second partition. Next, we are inserting GA, small g. P2, it is not there. Capital G, less than capital G, it should be partition 2. Partition 3, not there. P1 also not there. P4, it is there. It has gone to the default partition, max value partition. If we find the ASCII value of small g and capital G, small g is 103, capital G is 71. Small g is having higher ASCII value than capital G. That is why this value cannot be inserted into any of the partitions. That is why it has gone to the default partition. So when we have defined the table based on range partition on character data column, then the data will be inserted into the respective partition based on the ASCII value. It will check the ASCII value and then it will find where it is eligible. Wherever it is possible to insert, it will insert into that particular partition. Otherwise, it will go to the default partition. we don't have any data for date column. Okay, I think we have in hash partition. Now let us see list partition. How to create a table based on the list partition. Initially, the list partition is introduced to create the partitioned table based on the character data, very beginning in Oracle version 8 or 8i. But now we can create the list partition based on character, number, date, timestamp, time interval, anything. But originally it was created to support character data. Now we can create the list partition on any type of column, excluding that LOB, B file, raw, long, excluding these columns, normal data types, static data types we can use here. But mainly we go for list partition for character data only. Let us see, we are creating a partitioned table. We are just dropping if table is there, emp part list based on ename column, the same employee number, employee name, DOB, sal, 4 columns we are using here. We are creating the partition based on the character column, which is ename. Now partition P1 values A, B, C, P2 values P, Q, R, P3 values X, Y, Z. If the employee name is A, B, C, A or B or C, then it will go to the first partition. P or Q or R, it will go to the second partition. If the value is X or Y or Z, then it will go to the partition P3. Rest all other values will be discarded because there is no default partition here. A, B, C, P, Q, R, that is 1, 2, 3 will go to the first partition, 4, 5, 6 second partition, X, Y, Z third partition, D, S, T, U all should be discarded. D has given error, inserted partition key does not map to any partition. Yes, same error. T, same error. U, again same error. So these 4 records have got error and all these 9 records are inserted into the table. Now let us see, select star from EMP part list. We have all the 9 rows selected from the table. Now let us see, by selecting the data from each partition. From partition P1, we can select star from table name, partition name. The partition name must be enclosed in the parenthesis. We have 1, 2, 3, A, B, C, 3 records. Partition P2, PQR, 3 records. P3, X, Y, Z, 3 records. Remaining records are discarded. They are rejected. We can search based on employee number equal to C within a partition. If it is present, it will display. If it is not present, it will not display. See, we are searching for employee name C in second partition. No rows selected because there is no data by name C in the employee name field in second partition. Searching for employee name C from the table without specifying any partition, it will give wherever it is there, it will bring and display for us. It will search all the partitions. Now let us create list partitioned table with default partition. Let us try with max value. We know that max value partition is only meant for range partition, not for any other partition. So we cannot use max value partition in list partitioned table. That is why it has given error. See, the error is, it should be string, date, time, interval, number, or it must be null. So if at all we want to create default partition for list partitioned table, we must use null partition. Let us create that. EMP part list 1, same columns we are using, same partitioning we are using. We are using P4 values null. All the null values will go to the default partition. Let us insert 1 null, 2 empty string is nothing but null. Another record, we are not providing value for ename here, that means by default it will have a null. For the record number 3, committed. Now we are inserting the value D. A, B, C, P, Q, R, X, Y, Z. D will not map, S will not map, T, U, all these records are not mapping to any of the existing partitions. Now select the data. We have 3 records. In all these cases, ename is null. Now let us select from each partition. Select star from EMP part list 1, partition P1, P2, P3, P4. All the 3 partitions are null. We don't have any data. See the null partition, the last partition we have data, because P4 is the null partition. P4 is the null partition. So we do have data in the null partition, which is partition P4. So this is how we can create default partitions in the list partitioned table. So only null values can go there. Non-matching values will be discarded, will be rejected with error message. Hash partition. Hash partition was introduced in 8i and further enhanced in 9i. So we can create the table using hash partition in 2 ways. One way is we can specify the number of partitions and the names of the partitions. In second method, we specify only the number of partitions. We do not specify any names for the partitions. The names will be given by the database automatically. The main advantage of hash partition is it will help us to make the inserts faster. Inserting data into the table becomes faster because the incoming data will equally be distributed among the partitions and it will be keep on inserting continuously. So instead of inserting data into non-partitioned table and inserting data into hash partitioned table, if we compare the performance, inserting data into hash partitioned table will be faster because a single table will be treated as multiple tables because of multiple partitions. So each partition will act as a table. So if there are 4 partitions, it will assume that there are 4 tables. So it will be inserting the data into 4 different blocks so that the performance will be faster. When there is single non-partitioned table, a single block will be there. All the records have to go into the same block one by one. Series parallel it is not possible. So inserts become faster when we have hash partitioned table. But when we search will also be faster. Instead of normal table, if it is hash partitioned table, search will be definitely faster. But if we search for single record, then it will be faster. If we search a range of records, I want the salary between or employee number between 1 and 50 or 10 and 20. All the 10 to 20 records will not be present in a single partition. 10 will be in one partition, 11 will be in second partition, 12 will be in the third partition, 14 will be in the fourth partition. Again 15 will come to the first partition, like that. Since all the records are not available in the single partition, it has to scan multiple partitions. It should search where the actual record is present. So it will be little performance headache will be there in case of hash partition. But comparing to normal table, performance will be faster. But comparing to range partitioned table or list partitioned table, hash partitioned table, the performance will be bit slow in case of searches. And one more thing, whenever we want to create a table, a partitioned table based on hash partitioning, the number of partitions must always be in the power of 2, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, like that. That means 1, 2, 4, 8, 16, 32, 64. It should be like this. Then only the performance will be faster and the hash partitioning will be proper. If other than the numbers of power of 2, if we choose any other number, then it will create the partitioning table, but it will not give the complete results, the proper results of hash partitioning. Let us create now. Here we are using only 3 partitions, P1, P2, P3, P1, P2, P3. Partition table will be created, but it will not give the complete effect, all the features of hash partitioning. Partition by hash on DOP, on date of birth. Partition P1, partition P2, partition P3. We do not specify any values, we do not specify any range of values here. We just specify the partition name, P1, P2, P3. 3 partitions and each partition has a name. In the second type of hash partitioning, we do not specify the names, we just specify partitions 3. Create table, table name, partition by hash of DOB, partitions 4. We just specify only the number of partitions. The names of each partition will be given by the database, which will be starting with sys underscore, which will be generated through a sequence. Sequential numbers will be given. Let us insert now emp part hash. For the first table we are inserting, not the hash 1. First table 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 records we have inserted. Now let us see. In the table there are 10 records, there is no doubt. If we query P1, it has 4 records. P2, 4 records. P3, only 2 records. So when it is equally distributed, it must be 3, 3, 3 and 1 can be present anywhere. But here it is 4, 4, 2. Let us insert into second table. emp part hash 1. 1, 2, 3. 3 records we have inserted. P1 does not exist. P2 does not exist. We have inserted 4, 5, 6 again. P1 also not exist. P2 also not exist. We have not given any names for these partitions. The names are given by the database. We should know the names of these partitions, then only we can fetch the data from these partitions. 7, 8, 9, partition P1, nothing, 10. Totally 10 records we have inserted into EMP part #1. Now let us see what are the partition names which are created by the database for this table. For that purpose, we have one data dictionary view, user tab partitions, user table partitions, like that. User tab partitions is the data dictionary view where the information about the partitioned table will be stored, where table name equal to EMP part #1. See the partition name sys underscore P21, 22, 23, 24. These are the names which are given by the database. Each partition has its own name and the names are continuous, sequential, 21, 22, 23, 24. Now we can select the data using this partition name. Total 10 records are there in EMP part #1. Partition sys underscore P21, 4 records are there. P22, 3 records are there. P23, 2 records are there. P24, 1 record is there. So this is 4, 3, 2, 1. It is not like 2, 2, 2, 2 in each partition, and the last 2 records may be in partition 1 and partition 2. So partition 1, 3, 2, 3, 3, 2. Partition 4, 2. It's not like that. Some arbitrary order it is choosing to insert data into #partitioned table. See, first partition has 4 records. Second is having 3 records. Third is having 2 records. Fourth is having only 1. Now let us insert data into second table, which is created as #partitioned table by using partition name. We wanted to insert the value 10 into sys underscore P21 partition. 10 is present in 22. We wanted to insert in 21. See the error message, partition key is outside specific partition. Now when we use P22, it has inserted. P23, it is again error, because the employee number 10 is inserted into partition 2, P22, second partition. So we can insert this record into this particular partition only, not in any other partition. This is what is #partition. So when we do not give any name, the system will define the names for the #partitioned table, or along with number of partitions we can also choose our own names for the #partitioned table. It will not accept any value or range of value in #partitioning. It will use some hash algorithm and generate, or it will accept the records, how it can be inserted into the table, into each partition. There is no specific rule how the #partitioned table will actually be inserting the data. We don't have any specific rule for this. It will be choosing its own method to store the data into each partition of the table. Move on to composite partition. This is also called as sub-partition. That means, partitioning within the partition. The table is partitioned. Within the partition, again we will do sub-partitioning. Partition inside a partition. That is what is composite partition. We can also call it as sub-partition in our general terms. So what are all the combinations available for composite partitioning? Range means main partitioning will be range partition and sub partitioning will be again range partition. This type of composite partition or sub partition is allowed starting from 11G only. Before 11G, range composite partition was not allowed. Range list, main partitioning is range, sub partition is list. This is allowed and it is introduced in 9I. Range hash, main partition is range and sub partition is hash. This is also allowed. List range, list hash. These three combinations are introduced in 11G only. Main partition is list and the sub partition can be either range or list or hash, anyone. Next, composite partitions based on hash partition as base partition is not allowed. Hash range, hash list, hash. Composite partitioning is not allowed. Next, interval. In 11G, interval partition is added. So, supporting to this interval partition, interval range, interval list, interval hash. These three combinations are allowed starting from 11G release 1 as composite partitions. Let us see some of the composite partitions. Range. We have created the table. Up to here it is normal table. Partition key, partition by range. Partition key is employee number, which is number column. So first we are making range partition. After that, sub partition by range. Again we are doing range partition within the sub partition, which is for salary column.